coordinate geometry video, we'll be looking at some problem-solving questions using the distance formula. Here's our first example. So in this example, we have 3 points A, B, and C, and they are the vertices of a triangle. Vertices just means corners. One vertex, many vertices. We want to prove that the triangle is scalene. So that means we need to know what scalene means. Well, what's a scalene triangle? And a scalene triangle is a triangle where the lengths of all 3 sides are different. So we're trying to prove that it's a triangle with these corners and it's a scalene triangle. Let's just visualize the problem as well. So to do this, I've started by drawing an XY plane, a coordinate graph, and I've got my x-axis and my y-axis, and I've got my numbers on my axes. And since the 3 points that I'm interested in are all in the first quadrant, I focus on the first quadrant in my diagram as well. Now I'm going to plot the points. Plotting the points just means marking them on the diagram. So my points are 1, 1, 2, 4, and 3, 0. Take a moment yourself to just quickly sketch this. So I've marked my 3 points, and since I'm talking about the triangle that they make, I'm going to draw that triangle in also. So there's my triangle. So I'm trying to prove that this triangle is scalene, that all these distances are different. Now, it's not a requirement in this question to draw this diagram, but in some questions it will be a requirement, and sometimes even if you aren't asked, it can just be useful to be able to visualize what's going on. So what I need to do now is I need to work out what all those distances are. How long is AB? How long is AC? And how long is BC? If the triangle is scalene, they should all be different, so I don't expect to get the same answer for any of them. So since I'm trying to calculate length, I want to use the distance formula or the length formula. So I'm going to refer to it in my log tables and make a note of it on my page. And now I'll take pairs of points and calculate distance. I'm going to start with A and B. I'm going to label them x1, y1 and x2, y2. And then I'll fill them into the formula to find distance. So square root 2 minus 1 squared plus 4 minus 1 squared. Straight into the calculator, and I get an answer of root 10, and I'm happy to leave it in third form. Next, I'll take a different pair of points. I'm going to go for B and C. Again, I'm going to label them, and then I'm going to fill them into the formula. Now, it might be a good plan at this stage to pause the video here and try this one yourself, and then play and see if you're right. So in this case, BC will be 3 minus 2 squared plus 0 minus 4 squared into the calculator, and I get root 17. So they're the first two that I've calculated are different, and I'd expect if I've got a scalene triangle, the third answer will be different again. And the last pair of points that I have to select are A and C. So again, I'll label these 2 points. And again, pause the video here and do this bit yourself, and then play and see if you're correct. So AC is going to be equal to the square root of 3 minus 1 squared plus 0 minus 1 squared. Pop it into the calculator and you get out a solution of root 5. So I can see, looking back to my triangle diagram again here, that all 3 sides are different in length. But I don't want to just leave the question hanging at this stage. I want to clearly answer it. I'm asked to prove that the triangle is scalene. That means proving that all the sides are different in length. Well, I've done my calculations, and now I'd like to just wrap it all up with a nice conclusion. If you don't include a conclusion, having done your calculations, then you're not really showing that you understand what your calculations show. So how should my conclusion look? Well, I'm just going to state the obvious, really. I'm going to say, first of all, well, these 3 answers aren't equal. I'm going to use mathematical notation to do this. I'm going to say that root 10 is not equal to root 17, and it's not equal to root 5. So the numbers aren't equal. And then I'm going to extend that statement to refer to the sides of the triangle. I'm going to use a little symbol here which looks like an arrow with a double line coming into it. This symbol means this implies, or this line tells me what goes on this line. So in this case, these numbers being different imply that 3 sides AB, BC and AC are not equal. And if the 3 sides aren't equal, I can conclude that the triangle ABC must be scalene. So now a question for you. So here's your question now. A is minus 1, 2, B is 3, 5, and C is 7, 2. These are the vertices of a triangle. So I want you to plot the points on a coordinate diagram first of all, and then prove the triangle is isosceles. Pause the video here and have a go at this yourself, and then play and see if you're correct. So the first thing that I'm required to do in the question is to plot the points in a coordinate diagram. So I need to create that first. So I've set up my XY plane, and now I'll mark my points. So I've marked in A, B, and C, and now I'll join them to make the triangle. So here's my triangle, and it does look a bit isosceles. Now the thing is, I can't rely on diagrams to give me solutions, but I can use them to kind of give me a nudge in the right direction. So I'd kind of expect that if this triangle is isosceles, then it's most likely that it's because AB and BC are equal in length. Don't forget, isosceles means that two sides in the triangle match. So I'm going to start off by finding the distance from A to B, and then I'll get the distance from B to C, and if they're equal, then my job is done because the triangle is isosceles. I won't even necessarily have to figure out that third side. We'll be using the distance formula, so we'll need to refer to the log tables, and we'll write the formula on our page. So I'll start with A and B, I'll label them, and I'll fill into the formula. So the distance from A to B, or the length of the line segment joining A to B, will be equal to the square root of 3 minus 1 squared, and watch out for that double negative, that's the negative from the formula, and the negative from the x1. Of course, you can write this as a plus if you like, plus 5 minus 2 squared. And the answer comes out as 5, it's the whole number 5. And now I'll go on to find the distance from B to C. So B is 3, 5, and C is 7, 2. I'll label them, and then I'll calculate the length of the line segment that joins them. So it'll be the square root of 7 minus 3 squared, plus 2 minus 5 squared, and the answer comes out as 5. So the distance from A to B is 5, and the distance from B to C is 5. I can indicate on the diagram that these distances are equal in length by putting a little dash through each of those line segments. But remember, I'm not completely done until I've written down my conclusion. So take a moment at this stage now to think, what do you think your conclusion should look like? Think back to the previous example, and then see how you might be able to apply that layout here. Okay, well, first of all, I've noticed that my two distances are equal, really stating the obvious there. And if those two numbers are equal, well, it means that AB must be the same as BC. So this implies AB is equal to BC. And so what does this tell me? Well, it tells me that the triangle is isosceles. So I'll say, therefore, the triangle ABC is isosceles.